All right, so I would like for you to start today's lesson by going through this warm-up. So please go ahead and pause the video, and then we will chat about the answers to it. If you took a look at parts A, B, and C, we should have been able to figure those out pretty quickly, right? 32 times 10, because 32 is between 11 and 50, so they would be $10 each for $320. Whereas if you only buy 8, that means it's back at the original price of $12 per shirt, which would give you $96. And the last one being 85, it means that that is above 50 shirts, so that would be at $8 a piece. So 85 times 8. Now once you went down here, you might have looked at this and whatnot, but maybe you didn't, and that's fine. But this notation is called piecewise notation, and this is what we're working with today. If you notice, this completely describes the scenario that we have above. X representing the number of shirts. So that first one is 12 times X. So that would be for when you sell or buy between 0 and 10, right? So when we bought 8, we plugged it into that equation because it's between 0 and 10. Whereas when we had 32, we plugged it into the middle equation of 10 times X because 32 falls between those two barriers. And the last one, when we had 85, we plugged it into the last one because that is greater than 50. So what we're going to do today, and you'll see this a little bit, sometimes they'll just say find f of 85, and then you have to pick which one to plug it into. So you focus on these boundaries or barriers to determine whether you plug into one or the other, or whatever one it is, equation. Okay, so for this one, we would pick the last equation because it is greater than 50. So what this would look like if we were to graph this, okay, we would have something between 0 and 10. Okay, and this would be one of our barriers. And then we would have a different price between 11 and 50. And then we would have a different price from there on out. So it would look a little bit different. I'm just kind of estimating this. Okay. So if you just estimated this, obviously if I bought 0 shirts, I'd be at 0. If I bought 10 shirts, I'd be at 120. So I'm just going to put that there. Then we would jump into the next equation for 11. So if you buy 11, it's actually 110. So that would be here. So it would drop down, right? And then from there, you would then go to 50, right? And at 50, you would pay 500. So that would be like way, way up here, right? And then the next one at 50, you would be at 400. So it would drop down and then it would increase up. So these are just different functions depending on where you're at and what you're talking about. Okay, so that's what a piecewise graph looks like, and we're going to dive into it more right now. So we're going to look at the graph on the right. That's the graph of f of x equals 2 absolute value of x. How is f of x related to a linear function? So far we haven't really talked about this in a sense, because if you think about it, technically you have one function here, and then you have one linear function here, right? And you just don't worry about the other portion of it, right? Technically it's an x, not a v, okay? Because we have two lines that are crossing essentially, okay? So if you think about it, when x is greater than or equal to 0, so that would mean over here, all right, we would have one equation, and that equation would be that y would equal our y-intercept is 0, our slope is 2, right? We're going up 2 over 1, so it would equal 2x. But when x is less than 0 over here, then y would equal negative 2x, right? So these are technically piecewise graphs. What's happening is you have this boundary, which ends up being your axis of symmetry. Your axis of symmetry is your boundary, and it cuts it off into one piece and then the other piece. And they are two different functions, but just put together, they look like a V. So if we look at this one, this is just a different example of it, okay? Well, it's the example, but just shown to you, right, with colors. Oops, sorry. Let's look at number 2. We want to write the piecewise function represented from the graph to the right. Okay, now most of you are probably going to want to do an absolute value graph, which is fine, but we just want to show that this is actually a piecewise. So again, remember, this could be our boundary, right? So when we're writing piecewise, what we're doing is we're going to say if x is less than that boundary, which is -2, and if x is greater than that boundary at -2. Now in this one, you do need one of them to be equal to. It really doesn't matter in this case. It will in the future, but for this one, it doesn't matter. So when x is less than -2, that would be our left side, so over here. Okay, so I need an equation of a line over there. Well, it's hard to see where it's going to cross the x-axis, but if you continue going, right, it would just keep going like this, and there would be your line. So that means my equation, my y-intercept is 2, and my slope is 1, so it would be x plus 2. We would do the same thing for that orange one. This one's easier to see because it does cross the y-axis. Your slope this time is -1, and you're hitting at -2. So this would be an absolute value graph written as a piecewise function. Now we're going to dive deeper into piecewise functions that don't look like absolute values. We're going to start by graphing this. Okay, and whenever we graph, the first thing I want you to do is set your boundaries. So these boundaries are just these imaginary lines that mean that if you have an equation or a line or anything, it can only be on one side of that line. It can't be on both. So then we're just going to take each piece. So I'm going to focus on x plus 1. So I'm going to graph the line x plus 1, which means I would go up 1, and we would just go up 1 over 1, and we can go in both directions. But again, hopefully you're thinking, wait a minute, you said you can't cross that line, which is totally right. I need to determine whether this graph needs to be on the left or on the right. 99% of the time, the first one that you have is going to be on the left. Does it have to be that way? No, but we're pretty consistent. So because this says greater than or equal to, that means this is going to be a closed circle wherever it hits the line. And then we're going to just connect it on the left. That does mean we need to get rid of anything that we put on the other side of the line as well. For the second one, you have two options. You can just graph it like normal, but you obviously know that it's going to have to be to the right. That is where x is greater than 2. You can't have two lines on the same side of a boundary. But obviously I would start at 6 and then I would move my slope. So I would move down 3 over 2, which does hit at the same spot. We would have to go down 3 over 2 a couple more times, and then we can connect the dots. Now the only issue here is this does need to be an open circle for this one, and I do need to get rid of this other line. Other dot. The other thing that you can do, and you'll see me do this a lot from here on out, is what you can do is take your boundary and plug it in, because then that tells you where you should be on that line. So if we plug in +2 into our equation here, we would get -3 plus 6, which gives me 3, which means you would start at 3, which is where we are, and then you would move your slope. And you'll see that again in a second. So let's look at another example. Number 4. Again, we're going to start with our boundary. So our boundary is at 1. So I need a vertical line at 1. And then we're just going to graph each one. The first one is 2x minus 4, and it's where x is less than 1. So again, you can just start graphing it, but I'm going to show you how you can plug in. Remember, you can take the 1 and plug it in to the equation, and that tells you where to start. So we now have 2 minus 4, which gives me -2. So that means I should start at -2 with an open circle, because this is less than. And then I need to move to the left. Now this is a slope of 2, which means a positive slope. So normally I would go up 2 over 1, but now I'm going to go down 2 over 1. Now, although that looks like it might be a negative slope, remember you always read it from left to right. So if you're reading it from left to right, that is positive. And that's the part that people tend to do wrong. It's always that first one on the left that people go the wrong slope because it's backwards. So make sure you take a second to always check that. The next one is negative 3x plus 8. Again, you can just go up 8 and start moving, or you can take the 1 and plug it in. We get negative 3 plus 8, which is 5. So I would start at 5 with an open circle because it is just greater than. And then we move our slope of negative 3. So down 3 over 1, down 3 over 1. And notice how these don't hit at the same point like they have so far. They do not have to do that. Now, this part says, where is the graph increasing and where is the graph decreasing? Remember, increasing and decreasing is always talking about your x values, and it's always parentheses. So again, we want to read it from left to right, and I would focus on the left side first. So in this chunk, I need to determine whether it is increasing or decreasing. If you read that from left to right, that graph would be increasing. So farthest left is negative infinity. All the way to our boundary at 1, it is increasing. The other side of it, if we read from left to right, would be decreasing. That one starts at 1 and it goes all the way to infinity. Remember, parentheses and you're talking x's. Okay, sometimes you will have brackets for these specific ones, but I'll talk about that once we get to it. So now we're going to graph this one. This one looks a little different just because there's more boundaries. We are still starting with our boundaries, so we are focusing on these right here. So we have a boundary at 8, and we have a boundary at negative 2. So this one is the rare time where we have it backwards. The first one that we have is x, and it's where x is greater than 8, which means we need to start all the way over here in this category, because that's where x is greater than 8. So instead of moving it up 1 over 1, over and over and over and over again, what I want to do is take my boundary and plug it in, which means that I would just get 8. So that means that I'm going to start at 8 with an open circle, and then move my slope, up 1 over 1, up 1 over 1. We then would move on to our next one, which we just have 4. Because there's no x to plug into, that means that this is just the equation y equals 4. Well, that means that's a horizontal line. So we would go at negative 2 and at 8, and we would make a line through 4. We would have an open circle at negative 2 and a closed circle at 8 because of our inequalities. And then we have our last equation, negative 3 halves x plus 2. So again, I encourage you to plug in the negative 2. If we do that, we get 3 plus 2, which means we start at 5. This would be a closed circle at 5. And then we would move our slope negative 3 over 2. This does mean we would go up 3, left 2, so that it would stay as a decreasing graph, a negative slope. So again, it says, where is it increasing? Well, it's increasing in this range right here, which again, x values would start with 8, and it would go to infinity. Then it is decreasing, remember reading it from left to right, in this area over here. It's a negative slope. So that is from negative infinity to that boundary, which is negative 2. And then it asks for a constant. Constant is whenever you have a straight line. This happens between negative 2 and 8. And the 8 is included because it is a closed parenthesis. Which does mean I do need to change this. This is, sorry, not a closed parenthesis, a closed circle. Because that one is also a closed circle.